Okay, how does alcohol get into the bloodstream? And that process of alcohol getting into the bloodstream is called absorption. Now, first of all, obviously you have to consume the alcohol. But the alcohol is a drug that's in liquid form, and it can pass quickly through the stomach into the small intestine, and the majority of alcohol that gets into your bloodstream is absorbed primarily through the lining of the small intestine. There is a percentage of alcohol that gets absorbed through the lining of the stomach, but the largest amount of alcohol gets into your bloodstream as a result of being absorbed through the small intestine. And that rate of absorption can be influenced by a number of factors, and that rate of absorption can be variable. Rate of absorption is very, very important because it has an impact on how high your blood alcohol concentration will go, your peak blood alcohol concentration, and how quickly it will rise. So, obviously the amount and concentration of alcohol in the beverage influences the rate of absorption. So, if you're drinking a lot of alcohol, obviously you're going to influence the rate of absorption. You're going to be absorbing more alcohol and more quickly simply because you're taking in a lot of alcohol. The higher the concentration of ethanol, the more rapidly it's absorbed through the lining of the small intestine. So 40% ethanol per volume is absorbed more quickly than 5%. Pace of drinking is obviously going to influence absorption of alcohol. In other words, how fast are you drinking? So if you're consuming alcohol, if you're chugging drinks, drinking shots very, very quickly, you're getting the alcohol into your small intestine very quickly. That's going to increase the rate of absorption. Food in the stomach is very important. Food in the stomach actually can slow down the rate of absorption. Alcohol is going to be absorbed more quickly, and your blood alcohol concentration is going to go up faster if you're drinking on an empty stomach. It's interesting, the thing about the composition of food, and you know, there are stories out there that you hear that you ought to eat potatoes or carbohydrates. There's really not evidence that suggests that it's the type of food that you eat. It's more importantly that you have eaten something and your stomach is not empty. Another thing that can influence the rate of absorption of alcohol is something called gastric metabolism. And what this refers to is the ability of the stomach to secrete an enzyme that changes alcohol chemically. So if you can keep the alcohol in your stomach for a greater extended period of time because you have food in there, that allows this stomach enzyme to work on the alcohol, change it chemically, break it down even before it gets into the lining of your small intestine. And so that's going to help slow down the rate of absorption and total amount of alcohol that gets absorbed into the bloodstream. To understand absorption a little bit better, you have a much nicer depiction of the esophagus, stomach, and small intestine on your slide. But basically what happens, as I said earlier, you have to drink the alcohol, and again, it's a drug in liquid form, so it passes quickly down the esophagus into the stomach. And if the stomach is empty, the alcohol, since it is a liquid, passes quickly through this little valve area called the pylorus. And this is the gateway or the valve that regulates what gets into, eventually what gets into your small intestine. So if you're drinking alcohol on an empty stomach, and sometimes people do it intentionally because they've had the experience that, you know, they'll get a greater impact from the alcohol and it'll hit them more quickly because they're on an empty stomach. But in terms of blood alcohol concentration, that's not a good thing to do, because what happens is the alcohol rapidly passes through this little valve, gets into the small intestine, and once it's in the small intestine, the alcohol gets absorbed through the lining of the small intestine and gets into the bloodstream. This is no different than how nutrients, how protein and carbohydrate, for example, get into our bloodstream. The difference with food is, you know, that it's solid, and you know, your mom probably told you ever since you were a young person to make sure you chew your food. Well, chewing your food is important because in order for this food to be passed by the pyloric valve into the small intestine, it has to be broken down. It needs to be in the consistency of something like oatmeal. And in order to do that, to get the food into that consistency, you need to chew it well. And then also you'll have mechanical and chemical processes that break down the food in your stomach. So here's the benefit of having food in your stomach. If you have food in your stomach and it's occupying space there in your stomach, it's going to slow down the rate of the alcohol passing into your small intestine. Now, eventually, you will break down this food, and the alcohol and the broken down food particles will get through your stomach, and the alcohol as well as the nutrients then enter your bloodstream. So once alcohol gets into your bloodstream, it is circulated or distributed throughout your body. So what we're talking about here with alcohol absorption is actually when this gets into your bloodstream, we are now creating what is known as blood alcohol concentration, or BAC. Blood alcohol concentration, as we've talked about earlier, is very important in terms of DUI because it has an impact on sentencing and penalties in Pennsylvania. Now, what is blood alcohol concentration? Well, quite simply, it's the amount of alcohol that's in the bloodstream. And it's usually measured as a percentage. So, blood alcohol concentration refers to what percentage of an individual's total blood volume is made up of ethanol. And again, it's usually expressed as a percentage. And for example, a BAC of 0.10% is literally one tenth of 1% of your total blood volume. 1/10, the BAC of 0.10 is 1/10 of 1% of your total blood volume. So, if we were doing a blood test and I could draw 1% of your blood out of your body, I'm going to take out 1%. 99% of that of your blood is still in your body. I've only captured 1% of it, and I divide that 1% into 10 equal parts. So now we have 10 equal parts here of 1% of your blood. and I take 1/10 of that, take out the blood, oops, 8, I took out the wrong one. We'll leave the 9th one in. I take out 1/10 of 1%. So that's what I'm removing here. And I replace that with alcohol. So 9 parts of this blood are still blood, and 1 part is ethanol. That's 1/10 of 1%, or a BAC of 0.10. The reality is that it doesn't take a lot of alcohol in your bloodstream for alcohol to have its effects. Another way of looking at this is 0.10 literally would be 1 part of alcohol compared to 1,000 parts of blood. So the little graph that I gave you, or little chart on the next slide that I've given you there, what I've tried to do is represent blood alcohol concentration. And if you want to count them, you can count them, but there are 1,000 little red droplets of blood there. And then you can see the one, it's actually a little green droplet. That's ethanol alcohol. So if you have 1,000 parts of your blood and 1 part of that is made up of ethanol, that's a blood alcohol concentration of 0.10. What I'm trying to do here is create an impression that alcohol is a very potent drug. Unfortunately, I think it's a disrespected drug because it's commonly used. It's legal for people over the age of 21. It's highly advertised and been integrated into our lifestyle. And so sometimes people don't even think of alcohol as a drug, but it acts like all other psychoactive drugs in the brain. It causes the brain activity to be altered. And it is a very potent, powerful drug. Now, we mentioned earlier, too, in the law piece about 0.08 as being the per se level of intoxication. How could we represent a 0.08 in that little chart there that you have? Well, in that little green droplet, if you would just take off the little top of that droplet, that's going to represent about 0.08 blood alcohol concentration. And that's the per se level of intoxication where Pennsylvania says, no questions about it, you're too impaired by alcohol to be driving. We've talked a little bit about food in the stomach and identified that if you're drinking on an empty stomach, that allows alcohol, which is a central nervous system depressant drug in liquid form, to pass quickly into the small intestine and be rapidly absorbed into the bloodstream. Now, a couple other things that are a little different that we didn't touch on. And again, these are factors that can literally influence an individual's blood alcohol concentration. And another one of those factors is body weight. And body weight influences the amount of blood volume that we have in our bodies. So someone who weighs a little bit more than someone else, and they drink the same amount of ethanol, standard drink, over the same amount of time, and let's say on an empty stomach, the person who weighs more, because if you think of the body as a container, because their body is a larger container and it has more blood volume, they're taking in the same amount of alcohol that a smaller person is drinking. So by concentration, the alcohol that's in the larger person's bloodstream is going to be lower than the concentration of alcohol or the percentage of alcohol in an individual who weighs less. So body weight is a factor to consider in terms of influencing actual BAC. Two things that sort of go together, gender and percent body fat. Typically women have a little higher concentration of body fat than men. But the important thing here in terms of affecting blood alcohol concentration is the overall percentage of the body that's made up of fat. And if you remember when I said about if you understand some of the chemical properties of alcohol, you'll understand how alcohol works in the body. Well, here's this water-soluble issue. If you have a higher percent of body fat, alcohol is not very soluble in fat, as we've already mentioned. It's very, very soluble in water. So if your body is made up more of fat tissue, and you're of equal body mass as someone else, equal body weight, the difference is your body mass is different. You have a higher level of body fat. That's going to be less tissue for the alcohol to be absorbed in. Alcohol doesn't get absorbed in fat very well. And so a person who has a higher percent of body fat is going to have a higher blood alcohol concentration than someone who weighs the same, but their body is made up more of lean muscle mass. We talked about the gastric enzyme that's produced in the stomach that can help break down alcohol before it actually goes through the pyloric valve and into the small intestine. This is an interesting one in terms of gender. It appears that males produce a little bit more gastric alcohol enzyme than women do, and aspirin actually has been shown to inhibit the production of this gastric enzyme. And I think that's an important thing to consider because there are many people who are taking prophylactic aspirin as a cardiovascular protection, and it has been shown that prophylactic doses, ongoing doses of aspirin can actually suppress the production of this enzyme produced in the stomach. Carbonated gas or carbonation is an interesting thing. Carbonation gas, if you're drinking your alcohol in a carbonated beverage, that's going to speed up the rate of absorption. The carbonic gas moves the alcohol more quickly through the lining of the small intestine. And then a final factor that is important to consider in terms of your actual BAC is the health status of the liver. And that's because the liver is the organ that primarily removes alcohol from the body. And if your liver is healthy, your liver can eliminate about 1 standard drink per hour, or a little over ½ an ounce of pure ethanol per hour. And that's it. It can't handle any more alcohol. And so even if you have a healthy liver, you're going to be able to break down and remove about 1 standard drink per hour. If your liver is diseased or you have liver problems, then obviously if your liver is not functioning properly, you may not be able to even remove a drink an hour. So because you can't remove the alcohol at the normal rate that you would, that's going to cause your blood alcohol concentration to be higher. I've given you a little chart there to demonstrate the impact of body weight and I've given you three different body weights there: the 200-pound person, the 150 to 160-pound person, and the 100-pound person, and given them all one standard drink of alcohol. And so we're going to assume that all of them are on an empty stomach. We're going to assume that their percent body fats are the same. The only thing that's really different here is their body mass or their body weight. So the 200-pounder is going to have a little bit more blood volume than the 150-pounder. 150-pounder is going to have a little bit more blood volume than the 100-pounder. So what is the influence of body weight on actual BAC? Well, if we put one standard drink into the 200-pounder, we're going to raise their BAC to about 0.01. If we put that same drink, have them drinking exactly the same thing in the 150-pounder, that's going to raise their BAC to about 0.02. And in the 100-pounder, it's going to raise their BAC to about 0.03. Now, drinking one drink, that doesn't look like a large difference among these three individuals. But let's shift this a little bit to drinking actually 3 drinks an hour. And I don't think that's unrealistic. I think people can drink 3 beers or 3 shots or 3 mixed drinks in an hour's time. So let's take a look at what will happen if someone consumes this amount of alcohol, 3 drinks, 3 standard drinks in an hour's time. Again, one drink will raise the 200-pounder to a 0.01, so if we multiply that by 3, the 200-pounder somewhere after drinking those 3 drinks is going to be up to somewhere around a 0.03. The 150-pounder, one drink raises their BAC to 0.02, so if they drink 3 drinks in a relatively short period of time, like an hour, their BAC is going to be somewhere around 0.06. And then if you take a look at the 100-pounder drinking 3 drinks, with one drink raising their BAC to 0.03, their blood alcohol concentration is going to be up there around 0.09. Now, that's very important because we said the per se level of intoxication in Pennsylvania is 0.08. So here's an example of how important understanding the role of body weight in influencing your blood alcohol concentration. Here's a person who drinking 3 drinks an hour, like 2 other people, but has a smaller body weight and less blood volume. They've already exceeded a BAC already exceeded the per se level BAC of intoxication. So body weight is a very important factor in influencing BAC. In addition to factors that actually can impact your blood alcohol concentration, there are some factors that can impact how you feel at a particular blood alcohol concentration. So the difference here is we just went over a list of factors that can actually influence what your blood alcohol concentration is. These factors that we're going to talk about now, they won't alter your BAC. They won't change your blood alcohol concentration, but they may influence how you feel at a particular BAC. And we know things like mood and setting and expectations and even experience with alcohol affects how a person feels under the influence of alcohol. There was an interesting study that was done with some college students, and there was a sign-up list, come to a party at a certain bar, you know, there'll be free drinks, and that's a pretty good invitation for some individuals to go and get free drinks of alcohol. And so they didn't have any trouble in getting people to sign up. And so these college students went into the bar setting, normal bar setting, typical typical lighting, music, those kinds of things. And they were served pitchers of beer. And while they were being served pitchers of beer, they were also being videotaped. And as they consumed more alcohol, going back and looking at the videotape, it revealed that they started to exhibit signs of alcohol intoxication, alcohol impairment, starting to talk more, laugh more, volume went up, acting out a little bit. In other words, they were acting like their blood alcohol concentration was going up. The reality is they were being served non-alcoholic beer. And so what does this demonstrate? Well, it demonstrates that mood setting, expectations, and experience with alcohol can influence how we feel or think we feel as we consume alcohol. Another factor that's important that can influence how we can feel under the influence of alcohol is our fatigue level. Again, alcohol is a depressant drug. It slows down the central nervous system. It puts the brain to sleep from the outside in. Well, if you're already fatigued and tired, alcohol as a depressant drug is only going to intensify that feeling of being tired. So drinking when you're fatigued and you reach a certain BAC, you could feel quite differently than drinking to the same BAC, but not at that same level of fatigue. Another factor that can influence how we feel the impact of alcohol is something called tolerance. And tolerance is actually a shift in the central nervous system's ability to help us handle the effects of alcohol. So a shift in tolerance really refers to the body's ability to not allow us to feel as impaired as we used to feel at a particular blood alcohol concentration. Or another way of putting that is as the body develops a shift in tolerance, it takes a higher blood alcohol concentration to get the feeling of the effects of alcohol that we used to get at a lower blood alcohol concentration. This is very important. Someone that develops high tolerance to alcohol, in order to get the same kinds of feelings and perceptions that they got at a lower BAC, now have to drink more alcohol. And this can be a kind of a cyclic situation now where your tolerance continues to increase, so now you have to drink more to get the effects, the desired effects that you used to get. So tolerance, although it alters the way we feel, it's important to understand tolerance will not influence the individual's blood alcohol concentration. So someone who does not have tolerance and they're at a BAC of 0.10, and then after they develop tolerance and they're at a BAC of 0.10, just because they have tolerance, that does not do anything to change their blood alcohol concentration. What it does do is it changes how they feel at that blood alcohol concentration of 0.10. So the person with tolerance doesn't feel the influence of alcohol as much. So to get that desired effect, they now have to drink more alcohol. And another thing that can influence how we feel under the influence of alcohol is combining alcohol with other drugs. A common example of that has been some of these alcohol high energy drinks that were available. Some of them were being produced that actually, when the product was sold, it actually contained caffeine in an alcohol-related beverage. A a lot of problems started to result as a result of consumption of those products. They were also sold in large containers. The alcohol concentration in them was high, about 14%. They were being sold in 32-ounce containers. So when someone drank one of these beverages, they were not drinking one standard drink. They were literally drinking about 5 standard drinks. So their blood alcohol concentrations were going up, but the beverage also contained caffeine. So now what you have is you have 2 drugs. You have a depressant drug, the alcohol, and a stimulant drug, the caffeine, affecting the brain and how we feel. A misconception is that if you take a depressant drug and follow it up with a stimulant drug, you cancel out the effects of each, and you're at this drug neutral situation where you're not influenced by the drug. And that's completely inaccurate. If you take the alcohol and the caffeine, both of those drugs are in your bloodstream, both of those drugs get in your brain, both of those drugs affect the brain receptors that they would normally affect in your brain. The only difference is you feel different. When you combine alcohol and caffeine, you feel different than if you were drinking alcohol alone and if you were drinking caffeine alone. And what this combination was resulting in was literally people being very intoxicated but not feeling like they were intoxicated because of the effects of caffeine. So they were drinking more alcohol, becoming more intoxicated, were starting to show up in DUI-related statistics and crash statistics and injuries in emergency rooms. And so the Food and Drug Administration took a look at this, and they made a ruling that combining caffeine in an alcohol beverage actually is an adulterated product that's unfit for human consumption. So the FDA sent out warning letters to all the companies that were producing alcohol caffeinated beverages that were mixed together in the container, in the can or the bottle that you were buying. So it's no longer permissible to sell those products, alcohol products that are caffeinated. But that doesn't stop people from getting alcohol and caffeinated drink and mixing them on their own. And one of the popular ones is a combination of vodka and Red Bull. So you can actually buy Red Bull, which is caffeinated, but you can't buy Red Bull with alcohol in it. So the Food and Drug Administration no longer allows those things to be combined, but you can still buy Red Bull, which is caffeinated, and alcohol and mix them on your own. This is a very dangerous thing. It's called polydrug use, and it can have very serious consequences. And with the alcohol and the caffeine, the consequences were so negative that the Food and Drug Administration took action. Okay, we've talked a lot about alcohol in the body, blood alcohol concentration. Now we've got this alcohol in our bloodstream. What's the body going to do to remove that alcohol from our bloodstream? In other words, we've talked about our blood alcohol concentration increasing. How do you get the blood alcohol concentration to go down? And the organ in the body that has the primary responsibility for doing that is the liver. And the liver can only break down or remove alcohol at a constant rate. And that rate, by definition, is what we call a standard drink. And that's why standard drink is so important to understand. The liver can only break down or remove a little over half an ounce of pure ethanol per hour. So what we emphasized in terms of a standard drink is that the 12 ounces of beer, the 5 ounces of wine, the 1.5 ounces of whiskey at 5%, 12%, and 40%, they all contain a little over half an ounce of ethanol, if you remember when we looked at that calculation. So the liver, a phrase that's often used is the liver can only metabolize a drink per hour. And there's some accuracy to that, but the difficulty with that is what we mentioned earlier. You can get alcohol in non-standard size and concentration. So if you're drinking a 32-ounce beer at 12% ethanol, that is not one standard drink. So the liver, the concept might be a drink to me is one container of alcohol. So if the container is a 40, my concept is I had one drink. Well, because of the total volume of liquid, the concentration of alcohol, it's not a standard drink. So when we talk about the liver metabolizing one drink an hour, we must emphasize that we're talking about metabolizing one standard drink as we defined it. And what I like to emphasize is the actual amount of alcohol that the liver can metabolize. And that's just a little over half an ounce per hour. There's nothing we can do that can speed up the liver's rate or the liver's ability to increase that rate of metabolization. We just talked about the opposite of that, though. Someone who has an unhealthy liver may not even be able to handle a little over half an ounce of ethanol per hour. So how does the liver do this? One drink, standard drink as we defined it, or a little over half an ounce of alcohol. Well, what the liver does is it submits two enzymes, and it actually chemically changes the alcohol. It breaks the alcohol down into what are called metabolites. And the final action of these two liver enzymes converts alcohol, and if you remember, we looked at the chemical formula for alcohol, C2H5OH. When alcohol is finally metabolized by the liver, what is given off is carbon dioxide and water. So that is the final removal, or how alcohol is removed from the bloodstream. And again, the liver can only produce enough liver enzyme to break down a little over half an ounce of pure ethanol. Again, if you understand the properties of alcohol, since these are the byproducts of liver metabolization, this is the reason why a urine test is not a good test for ethanol. You do give off a little bit of alcohol unchanged in urine, but it's very inconsistent and it's very erratic. So a urine test is not a good test for alcohol metabolites in the bloodstream. And other things can produce carbon dioxide and water in the bloodstream. Now, urine tests can be good for metabolites of other drugs, but the best tests for measuring alcohol in the bloodstream are the breath test and actually doing a blood analysis. And blood analysis has probably become more common now than even breath test, because when you do the blood test, it's obviously very accurate for alcohol, but it also allows you to test for other controlled substances that may be in the bloodstream. Okay, let's use this information about the liver's ability to remove alcohol And let's take a look at the 200-pounder, 150-pounder, and 100-pounder. And we talked earlier about drinking 3 drinks in 1 hour. And what we identified was that those 3 drinks would take the 200-pounder up to about an 0.3, 150-pounder up to about an 0.6, and the 100-pounder up to about 0.09. So now what we're going to do is we're going to allow an hour to pass by. We're going to give the liver an hour of time to break down and metabolize 1 standard drink. So going up, 1 standard drink raises the blood alcohol concentration of the 200-pounder to 0.01. So what we have to do is subtract out that equal amount as the blood alcohol concentration is going down. So in 1 hour, we have to take a 0.01 and subtract it from the 0.3. So that individual, if 1 hour passes, is going to be around a 0.02 blood alcohol concentration. Since the 150-pounder, 1 drink raises their blood alcohol concentration to 0.02, we have to subtract that same amount out with their blood alcohol concentration going down. So we take out 1 drink from that individual, and they're now at about a 0.04. And then the person whose BAC went up to a 0.09, the 100-pounder, 1 drink raised their BAC to 0.03. So the 3 drinks took them up to the 0.09. Now we're going to take out 1 drink. So we have to subtract the 0.03 from 0.09, and they're now at a 0.06. So you can see the removal of the alcohol is progressive over time, and it's also influenced by body weight, because body weight can influence how high the blood alcohol concentration gets. Body weight does not influence the liver's ability to produce the liver enzymes to remove the alcohol from the blood. What body weight did was it influenced the peak BAC that these individuals reached. But there really isn't anything that, that we know of that can efficiently and in a very simple manner stimulate the liver to break down alcohol and remove it at a faster rate than a little over ½ an ounce per hour. Spent some time obviously talking about factors that influence blood alcohol concentration, but what I want to emphasize is we can estimate blood alcohol concentration, but it's very, very difficult to accurately calculate blood alcohol concentration. And the reason for that is all of these factors that we already talked about that affect blood alcohol concentration. So if you're using a BAC chart, for example, it might have a person's body weight listed. It might have a standard drink listed, and then it shows BAC increasing with each drink that is consumed. That is at best an estimation of blood alcohol concentration. It's not an accurate calculation. And the reason is, you already know the reason why. We don't know the individual's percent body fat. We don't know if the individual has had any food in their stomach. We don't know the pace of their drinking. So I want you to be able to understand that we can estimate BACs based on body weight, how much we've consumed, and the concentration of alcohol. But it's only going to get us in the range, in the ballpark somewhere. I would not recommend that if you get pulled over for a DUI, you pull out the BAC chart and tell the police officer, in the online version of the Alcohol Safe Driving School, I learned that my BAC is right here, because there's a good chance that it's not, based on these other factors like pace of drinking, food in the stomach, and percent body fat. So what I think is a more appropriate thing to focus on and be more concerned about is just this very simple understanding that if you're drinking more than 1 drink an hour, and that standard drink, as we talked about it, or a little over half an ounce of ethanol, you now know for certain that your blood alcohol concentration is going up. If you're allowing enough time to pass for your liver to break down that alcohol, if you're drinking less than 1 drink an hour, that's going to allow enough time to pass for the liver to break down the alcohol, and you're going to have a very, very low blood alcohol concentration. So this simple concept, I think, is very, very important. I just want to come back to something we mentioned on a prior slide or a prior slide that you have on your presentation there that you're looking at, and this was in our discussion of factors that can influence how we feel under the influence of a drug, and I just want to make sure that you have a good understanding of tolerance. And so simply put again, tolerance is the reduced effect of a drug after prolonged exposure. So in other words, there is less sensitivity to the drug. The chart that we were talking about earlier, I was referring to alcohol. I just wanted to make sure that you understand that tolerance also can occur with other drugs. So tolerance is not just limited to alcohol. So the important thing here is your central nervous system develops less sensitivity to the drug, and now it's necessary to take more of the drug to get the effect that you used to get at a lower amount.